Let's go to Unit 2. Here's polynomials. So we'll start with the factoring. We spent a lot of time on factoring, and we did kind of 3 different ways once we got to polynomials. And the first one that we found was important was the GCF, which means greatest common factor. So you can add that in there if you want. For example, let's say we had something like 2x squared minus, how about 50? Okay. The greatest common factor of those two is 2 because they are both divisible by 2. So that means we could factor out a 2 from them. So 2 times x squared would give me 2x squared, and 2 times 25 would give me 50. So it'd look like that. And the next one we looked at was this little formula here, the difference of squares. In this case, you would see something like this, x squared minus 25. So there's no b, so that's why it looks a little bit different. So we would look at this one, for example, x squared minus 25. Well, that's x squared and 5 squared. So that's x minus 5 times x plus 5. And then the last one was these here. These are the sum and difference of cubes. So we know we won't mix these two up because I will only use this when I see something is cubed. If I don't see something cubed, I see things that are squared only, I'm going to just refer back to this one. So the next one says, how do I operate on polynomials? We did a few things. We added them, we subtracted them, we multiplied them, and when we multiplied them, we distributed, or we did the box method. And you know you are going to use those when you see like addition and subtraction in between them. And then the last thing we did to operate on them was division. And division, we had synthetic division. We also had long division. And we know that we had to watch out for remainders. So we need to know, what do we do if there's a remainder? Okay. So if you see one where you do the synthetic division and the last number is not a 0, so there is no remainder, then that's nice. But if it is something else, then you have to make sure you put it at the end and write it over whatever you were dividing by. So look to your study guide for an example like that. And then the next one says, how do I tell the difference between a factor and a root? And remember, root can also be called a 0, an x-intercept, any of those. Well, let's just do an example. Let's say the factor is x plus 2. To find the root, I set that equal to 0. If I set that equal to 0 and solve it, I'll get x equals negative 2. And this is where it crosses the x-axis. So this is the x-intercept, the root of 0. And the next one on this page says, how do I find zeros or roots and factors of polynomials? So how do I actually find these things? Well, we had a couple of methods. One way was graphing. So we could look at the graph and find where does it cross the x-axis. Those would be our roots. We could work backwards to get the factors. We also did synthetic division or long division. You can choose what you prefer, but you don't have to do both. And the synthetic division was when we were given a factor, because then we know exactly what to divide by and there shouldn't be a remainder. Once we did the synthetic division, then we had to factor it and finish it off to find the remaining factors and zeros. But those were the main methods that we used in class. So let's go to the next page. Wrapping up polynomials right now. The next ones are talking about what are the graphs looking like. So these would be where you're trying to match the graphs. So what kind of end behavior do polynomials have? So what happens on the left and the right sides? Well, in our table, let's look at even degree. So that would be like x squared, or maybe 2x to the 4th, or 3x to the 8th. Anything that has an even degree as the highest one. So if it's even and it has a positive leading coefficient, if I were to graph all of these, I would find that on the ends, they all go up. Now if I throw a negative leading coefficient, meaning I put like negative in the front of them, that's going to switch them and now they're going to go down. And then I can look to my odds when it was positive, so that'd be like maybe like 2x cubed. So that means that if it's positive, it actually started down and then up. And then once I make it negative in front, so if I put a negative here, all of a sudden it's going to switch, and now it looks like that. And then my last one, what does multiplicity of roots look like on a graph? You could even call it zeros. Any is okay. What does multiplicity of roots look like on a graph? So let's just write down a couple of examples. So let's say we have a factor. You see something like this in the equation. I want to look for, what is that going to look like at the root? Well, this tells me the multiplicity, which is 2. So this has even multiplicity. And the root, if I set this equal to 0, because this is the factor, would be x equals negative 3. So that means it's going to, since it's even, it's going to bounce at x equals negative 3. So the graph is going to come up to negative 3, and then it's going to go back. And then let's look at a different example. So let's say x minus 1 to the third. Now the multiplicity is 3 on this one. So this multiplicity is odd. When the multiplicity is odd, that means that it's actually going to cross through the axis. So in this case, it's going to cross at x equals 1. And that is it for our polynomial function, or sorry, polynomial unit.